Welcome to HNL News, Episode 17. I'm H, and this week's digest has it all, from technologies that fit on your fingertip to discoveries that flip our understanding of the universe's youth on its head. Next to me is L, who, as always, has already fact-checked everything and calculated the risks.
Correct. And the first risk is that our listeners might not grasp the scale of a microscopic breakthrough against a cosmic one. But let's start with energy, the foundation of everything.
Let's begin with the quiet energy revolution. Scientists at Kyushu University in Japan have made a breakthrough that could finally make hydrogen fuel cells practical. They've created a new material based on scandium oxide that allows for efficient proton transport at around 300 degrees Celsius.
To grasp the significance, modern solid oxide fuel cells, SOFCs, operate at 700 to 800 degrees Celsius. This requires expensive heat-resistant materials, making the technology complex and costly. Lowering the temperature to 300 degrees Celsius is an opportunity to make hydrogen energy more accessible to the consumer market.
The secret lies in creating a so-called SO6 highway. Scandium atoms form a wide, smooth path for protons in the material, preventing them from getting stuck. It's like turning a dirt road into a freeway for charged particles. But Lel, scandium is a rare and expensive metal, right?
Exactly. This is a classic technological dilemma. Scandium is a rare earth metal, and its price can reach thousands of dollars per kilogram, creating a barrier to mass adoption. A lab breakthrough is the first step, but the next is finding ways to reduce production costs or discover alternatives.
While we contemplate the energy of the future, the present reminded us of its fragility with a global outage. On December 5th, a Cloudflare disruption affected giants like LinkedIn and Zoom. The company fixed it quickly, but this episode is a stark reminder of how fragile the digital ecosystem can be when so many services depend on a single infrastructure.
This demonstrates the single point of failure concept. The outage highlights the need for decentralization and resilient cloud architectures. And for regular users, it underscores the importance of having offline alternatives for critical tools.
And while big systems fail, small ones make breakthroughs. MIT has developed an AI chip the size of a grain of salt, integrated into an optical fiber. It uses a diffractive neural network to process images, literally at the speed of light.
The principle of photonic computing allows it to bypass the speed and energy consumption limitations of traditional electronic chips. Potential applications range from instant medical diagnostics to creating absolutely secure quantum communication lines.
Moving on to body and mind. New research will delight coffee lovers. 4 cups a day may lengthen telomeres, the protective caps on chromosome ends that serve as a marker of biological age. The effect is comparable to rejuvenation by 5 years, but importantly, the study was conducted on a sample of people with mental disorders.
And a key clarification already have a harmful effect. As with everything, the dose matters. This is interesting observational research, but it does not establish a cause and effect relationship and is not a guide to action.
Another promising news in the fight against obesity is the hormone FGF19. Scientists have found that it activates fat-burning cells directly in the brain, paving the way for an entirely new class of drugs.
This is a more targeted approach than general metabolic impact. However, the path from discovering a mechanism to a safe drug is many years of clinical trials.
And in material science, a sensation! Scientists have managed to make ordinary semiconductor germanium superconducting.
If the discovery is confirmed and the technology scaled, it could become the foundation for creating more stable and efficient quantum computers and revolutionize the design of energy-efficient chips.
And now for the most spectacular part. The James Webb Space Telescope continues to rewrite textbooks. This week, 2 discoveries. First, a new tiny moon of Uranus with a diameter of only 10 kilometers has been detected. It received the preliminary designation S/2025 U1.
This is classic cataloging and refinement work of our own solar system. Each such discovery helps us better understand its formation history.
And the second discovery is truly fundamental. The telescope has detected the spiral galaxy Alaknanda, which formed just 1.5 billion years after the Big Bang.
This is revolutionary. According to prevailing models, in such an early era, the universe should have been filled only with chaotic, shapeless clumps of gas and stars. Mature spiral galaxies, like our Milky Way, were thought to be the product of many billions of years of quiet evolution.
But Alaknanda is a full-fledged spiral with clear arms and a central bulge. It not only existed incredibly early, but also gave birth to stars 20 times more actively than the modern Milky Way.
This discovery calls into question existing theories of galaxy formation, the LCDM model. It proves that the processes of structuring the universe proceeded much faster and more efficiently than we thought. Alaknanda is not an anomaly, but part of a growing sample of overly developed early galaxies found by JWST.
And now, a quick rundown of other important topics of the week. The UN has declared 2025 the International Year of Quantum Science, and Microsoft has introduced the Majorana 1 chip for industrial quantum computing. A group of scientists has issued a declaration on climate tipping points. Warming is likely to exceed 1.5 degrees Celsius, which could trigger irreversible chain reactions like permafrost thaw. We are in the danger zone. Finally, for a laugh, by the end of 2025, they promised the release of the Leo solo flying motorcycle. A breakthrough in personal transport or an expensive toy? Time will tell.
We are observing an acceleration of scientific and technological progress on all fronts, from microscopic chips to cosmological scales. In parallel, systemic risks are also growing. Infrastructure fragility, climate threats, and ethical challenges of new technologies.
On that note, we're signing off. Remember, the future is created at the intersection of disciplines. Today's breakthrough in materials physics will provide clean energy tomorrow, and a discovery in cosmology will rewrite our textbooks. Stay curious.
The level of innovative entropy this week has increased by 9.2%. Recommended for thoughtful assimilation. Subscribe, comment, suggest topics. Until the next episode.